So hello and welcome everyone. My name is Jay Dalsaniya and in this video we are going to solve the problem K-Pangrams. Okay, so the problem statement is quite interesting and there will be something new that you will be learning in this, that is what is panagram. Okay, so without wasting any further time, let's start the video. So given a string str and an integer k, return true if the string can be changed into pangram. After at most k operations, else return false. So you'll be given a string and an integer k, and you are supposed to return true if this string can be converted into pangram. And the operation that you can do is basically you can have at most k operations and you can change the k characters inside the strings. Okay, so that is what it says. And here the definition of operation has been mentioned, that is basically a single operation consists of swapping an existing alphabetic character with any other alphabetic character. Okay, and the definition of pangram has been mentioned as a pangram is a sentence containing every letter in English alphabet. Okay, so let's try to take the first examples and let's try to understand. So as I basically teach in every class of mine, so how to read a problem statement, basically go through the problem statement once, and then after it, don't get too confident that you have understood everything regarding the problem. Have a look at the examples because sometimes you might miss something in the quotient understanding, right? And it's very important to have a look at the constraints ones. So go through the constraint one, because whenever in the future you write down the code, basically I'm talking about a particular question, you will be having an idea what kind of data structure you can use, what kind of variables, what are the different types of data types that will be helpful to solve that problem. Okay, so first of all, read the problem statement, examples, and then the constraints, and then start solving the examples. Okay, so let's start by the first example that has been mentioned over here. Let's try to understand with the help of example. Okay, so here there is a sentence given that is the quick brown fox jumps over the lazy dog. So what is your question saying? Question is saying that after applying k operations, okay, this is at most k operation. You have to verify whether the given input string can be converted into a pangram. And pangram basically means a sentence that contains all the alphabets of English. So you are supposed to find out whether this string can be converted into pangram. Okay, so here you will be given a string and this string contains a space as well. The delimiter over here is basically a space, and the value of k will also be given to you. That means you can basically change at most k character from the given string. So here the quick brown fox jumps over the lazy dog. This is a very famous statement, and this entire sentence basically has all the alphabets from A to Z. So you don't need to apply any operations. You don't need to apply any key operations over here, and hence the output comes out to be true. That means it is a panagram. Input string already is a panagram. Okay, so let's take the second example, which is mentioned in the uh, problem statement. You will be given a string, okay, and there are so many alphabets over here, right? A repeating A is mentioned over here, and the value of k is mentioned as 25. So let me tell you how many alphabets are there. So basically the length of this A is basically this string is of length 26 and there are 26 characters and all those characters are A. Now here k equals to 25, that means you can change 25 characters from the given string to any other alphabet. Okay, so obviously if you keep on changing each and every alphabet, we need all the characters from A to Z. So I'll change this A to A, I'll change this, so this is not required, right? You don't need to change this A. I'll be changing the second one to B, to this one to C, D, E, F, and in this manner I can change all the remaining 25 A into the characters that are missing, and hence after applying 25 operations, at most 25 operations, you can create or change this string into a panagram. Hence the output comes out to be okay. So here so here in both the examples you are getting output as true. So basically they are saying that you will be given a string. Your focus is that you are supposed to convert the given string into pangram. A pangram is a string that contains all the alphabets from A to Z. But how will you convert the given string into pangram? If it is not a pangram, you will be given a value of k. So they are saying that at most k operations, basically you can change at most k characters in the input string, and after changing at most k characters in the input string, can you convert the given string into a pangram? Yes or no? You are supposed to return that only. Okay, so I hope you have understood the problem statement. Now we can focus on understanding how to solve this problem statement. So let's understand. So here there are few observations that you should keep in mind, right? So what are the key points that the question is mentioned? So question is saying that you are supposed to convert a given string into pangram. And what is a pangram? Pangram basically is a string that contains all the alphabets from A to Z. And how many alphabets are there in English? There are 26 alphabets, right? So you should ensure that all the 26 alphabets are present inside this string. Okay, fine. So you can apply some operations, right? And they have mentioned that you can change at most k characters. So I'll write down at most k characters can be changed. Okay, so now here, if I have a look at the example number 2, here you can see what is the length. So everything revolves around counting the frequency of the characters, right? Why? Because you are supposed to ensure that all the 26 alphabets are present. That means you are supposed to ensure that unique 26 alphabets are present in the given string. Okay. So everything revolves around counting the frequency of this 26 characters. Okay, and all of its frequency should be greater than or equal to 1. So what I will be doing, first of all, one observation should be clear. I'll give you an example. Let's take some example test case number 3. Now I'll write down A, B, C, D, E and F. And let's say I am giving you k equals to 25. Now for this string, can you convert this string into a pangram? Pangram means 26 characters should be there, all the characters, right? But here you can see what is the length of this string, A, B, C, D, E, F. The length of this string mentioned over here is 6. And now we know that for a string to be a pangram, its length should be at least 26. Now here, even though I apply 25 operations on the given string, I will not be able to add any new characters to this string so that its length from 6 will be changed to 26. So obviously for this example number 3, it is not possible to convert this into a pangram. So I'll be returning false as the output. Okay. Let me take one more example. So let's say test case number 4 and I'll write down Z, X, Y, Z, P, Q, R and A. Okay. And let's say even though I will be giving you k value as let's say 30. So that means you can change at max 30 characters over here. Now what is the length of this string? So this is 3, this is 3 and this is 2. 6 plus 2, that is basically 8. So the given length of this string is 8 and I am supposed to create a pangram whose minimum length should be 26. So I cannot basically, even though I can change 30 characters, I cannot increase the length of the given string, right? I can just change the existing characters to something else. So for this example also, test example number 4, the output comes out to be false. Okay. So what can you observe from this? So basically, you can observe that if the length of unique characters over here, I repeat, if the length of unique characters in the given string is less than 26 or the overall length, okay, if the length of the string is less than 26, then at no cost you can basically convert this string into a panagram. It's never possible. It's not going to be possible. Okay. So if in the initial stage you will be given a string that will contain the delimiter space as well, right? So you are supposed to ignore this special character space, and I'm just talking about the alphabets A to Z. Okay, so I have observed one thing. So I'm writing down some observations over here. I'll be writing down with this, and let me call this as the algorithmic steps. So if I see if the length of this string is less than 26, then I can directly reply that answer is not possible. I'll just respond with a no, answer is not possible. Okay, fine. So how will I find out whether all the characters are present or not? Okay, so this example is clear. Now what about these strings with length greater than or equal to 26? Okay, so let's have an example, have a look at this test case number 2. So in the test case number 2, you can see what is the length of this string. I have calculated the length. So the length of this string is what? 26. Okay, fine. So now for this example whose length is greater than or equal to 26, you need to ensure whether this value of k will help you to convert it into a pangram or not. So now the observation or the answer depends upon the value of k. So now here identify how many alphabets are present. So what is the length of the string? It is 26. Okay. And how many characters are missing? I can see all the characters are A. So from 26, one character is present over here. So I am still having a count of 25 that represents the missing alphabets. So there are 25 missing alphabets. Now tell me one thing, you are given k operations and you can change at max 25 characters. So can you get all these 25 missing characters over here by applying this at most 25 operations? Absolutely yes, right? You can apply 25 operations, you can change 25 characters over here and you can get all these missing characters back to the string, right? Now, as I mentioned that if the length of the string is basically greater than or equal to 26, every time doesn't mean that answer is possible. Why? Let's say if I change the value of k to something else, if I change the value of k equals to, let's say, 1 3 13. Okay, so that means I can change for the given string at max 13 characters. Now I know the length is what? Length is 26. How many characters are present in the range a to z? One character is present. So how many characters are missing? So this indicates missing characters. I'll write down missing characters. So 25 characters are missing. Now tell me, after applying at most 13 operations, after changing at most 13 alphabets, can you get all these 25 missing characters? Obviously not. Some of the characters will not be still present inside this string, right? So here for this example, the output comes out to be what? The output is basically false. It is not possible to convert it into pentagram. So what did we observe over here? We observed that if the missing characters count, if the characters that are missing, if the missing character count is basically less than or equal to k, then and only then I can say yes, you can convert the given string into pentagram. Else, if let's say if the missing character count, that means the characters that are missing are more compared to the operations that you are allowed, then in that scenario the output is not possible. And these two observations are for what kind of test cases? They are for the test cases where the length of the string, if the length of this string is basically greater than or equal to 26, if the length of this string is what? Greater than or equal to 26, then you have then your answer depends upon the value of missing characters and the value of k. Okay, so here is the entire algorithm. So I have divided it into two sections: a string with length 20 with length less than 26 and a string with length greater than or equal to 20. So this is the entire algorithm. I hope you got an idea what we are supposed to do. Okay, first of all, identify the length of the string. If it is less than 26, then answer is not possible. Okay, because minimum length of pentagram will be 26. Now, if the length is greater than or equal to 26, then answer may or may not be possible. And the answer depends upon the value of k. So if the missing character is less than or equal to k, then that means answer is possible. You can convert it into pentagram. If the missing characters are more compared to the operations that you can do, then answer is not possible. Then you are supposed to return no. Okay, so this is the entire algorithm. Now I think we can move to the implementation part of it. Okay, I have shown you the algorithm. You can take the reference of this algorithm to code the approach in other languages as well. So let's see, I have written the code in Java, but same can be implemented in other languages. So here is the function K-Pangram, and you are given the string str and the integer k. And this input string may contain the delimiter, or basically the strings are separated by space over here according to the example 1. So I'll be not considering space as my character. So I've created basically a Boolean frequency array, and that will help me to count the unique characters that are already present inside this string. Then I have taken the integer total that indicates how many characters are present, because I cannot directly take the length of this string. Why? Because here in the first thing, if you see, space is also a character, and if you take space as the count or a character, then your answer will be wrong, right? Because you cannot convert a space to some character. It is not mentioned. So total indicates how many total characters are present, and here int character present indicates how many unique characters are present in the range a to z. So I'm starting the iteration over the entire string, and if I find a string or the character is basically the space, then I'm going to skip that character. Now if the character is not a space, then what I'm doing, I'm just finding out the integer value in the range 0 to 25 so that I can map inside the frequency array. So I've found the value inside value array. Now I am considering this as a character which I can change if required. So I'm incrementing my total count of characters. Then I am checking if the frequency of this character is already updated. That means if this character has already been marked as present, then I'm not going to again mark it present because I'm going to count the unique characters, right? This character present count. So if the character I am encountering for the first time, then I will mark its present inside the frequency array as true, and then I will increment the unique character count, that is character present. Now, if I find that the total characters that are present are less than 26, then we already saw if the length of the string is less than 26, then output will always be false. Now, if the total characters are more than or equal to 26, then our answer will depend upon the value of k. Now I am finding the count of missing characters. So we know that 26 characters are there in English alphabet. So I am subtracting the unique characters that are already present. So I will be needing this many characters to be inserted or to be replaced. So if my missing count is less than or equal to k, then that means I can convert it into pentagram. If not, then I cannot convert it. Then I will be returning false. So this was the entire implementation, and the time complexity of this approach is going to be order of length of this string, and the space that I have utilized is a constant sized array that is of length 26. So the space complexity of it is going to be order of 1. Now let's try to submit this and let's get our problem submitted. And we can see that the problem has been successfully submitted. So that was it for in this video. If you really enjoyed this solution, then do hit the like button and share down your approaches in the comment section below. Till then, keep coding. I will be seeing you in the next video. Thank you.